Welcome to Reporters Roundtable. I'm Rafe Needleman in San Francisco. Today I'm going to ask you to indulge me in covering one of my favorite technology topics, which is mesh networking. The connection between your wireless devices and the global communications network is a tenuous thing. Wi-Fi links are great when they work, but gadgets spend a lot of time out of range. And cellular links? They're dependent on commercial and surprisingly vulnerable cell towers. While few of us in the developed world have experienced a critical lack of connectivity in our lives, it can happen at any time, and it can be life-threatening. During a natural disaster, the communications infrastructure can fail due to power outages or panic-driven overuse. When a repressive government threatens a population, usually the first thing they try to control is their citizens' communications with each other and the outside world. Mesh networks, in theory, are more robust than point-to-point communications. In a mesh network, any device with a connection can share that connection with other devices. It's hard to shut down or censor a mesh network by strangling it at just one point. It's also hard to spy on what's happening on a mesh network, which is one reason the technology is used for military communications. Can mesh networks make our existing Wi-Fi and cellular networks more robust, cheaper, and safer? Can they give voice to the oppressed or the censored? Today we're looking at the latest mesh technology products and the interesting places they could take the communications industry. Our guests today are two longtime experts in mesh networking technology. First, Sri Krishna, who's the founding CTO of the mesh networking company Tropos, which was just acquired by the power infrastructure company ABB. Congratulations.
Thank you.
Now that Sri has left Tropos, he's trying to bring mesh technology to people around the world. We're going to discuss what that means as the show goes on. Again, congrats and welcome.
Thank you.
Also joining us is Misha Benoliel, the CEO and co-founder of Open Garden, a consumer mesh networking company that's trying to bring mesh to a different group of people, which is you and me. Welcome to you, and congratulations on your great showing at the TechCrunch event a couple of months ago. So I want to do what I like doing here, which is start from first principles and then build up from there. So let's discuss technically what is a mesh network and why we need it. Misha, let's start with you.
Mesh networks are a technology that have been existing for a while now, and it's completely timely for mesh networks to improve connectivity for everybody today. And when you see the limitations we have with 3G, 4G technologies, Wi-Fi network access, mesh networks can help a lot to improve the situation and bring to every consumer ubiquitous access to the internet.
But technologically, in a nutshell, what is it? Instead of my phone connecting to a tower, my phone connects to another phone? Sri, how does that?
That's right. So the original mesh networks were designed in the military for survivable communication, so that soldiers could communicate with each other in the most harshest conditions. Mm-hmm. And they have some very powerful radios that they connect to, so that they can communicate over tens of kilometers and get back, and talk and get data. And these are without any infrastructure, because the soldiers can't have any infrastructure when they're in a battlefield situation. So that's what the idea of a mesh network is. And so since the initial application of mesh networks in the military, there have been many different variations of mesh networks that have been used throughout the world, both for cities as well as for small scale inside buildings, for utilities across very large areas. And as well as the peer-to-peer meshes like Open Garden, where people are trying to connect with each other.
So I guess the idea here is that one device can connect to touchdown to or connect to the rest of the internet through another device somewhere that is connected to that has a touch point. And as I understand it, when I first heard about this technology many years ago, I thought, wow, this is magic. Why aren't we all using this? And then I started to talk to guys like you and understood that there are technological challenges of actually building a mesh network that in theory it's great, but there are problems with computational overhead and battery life. Can you talk about that a little bit?
Absolutely. So when we started Open Garden, we had to face many technical challenges. First, we had to enable devices to recognize themselves seamlessly and avoid processes like discoverability or pairing. Because if you want a mesh network to be efficient. You want to be able to access to someone else's device to have connectivity without any interaction with your own device or any other interaction for the person who is going to provide you with connectivity. So these were the first barrier we encountered when we released our software, before we released our software. And we found a way to avoid discoverability and pairing. And one use case we can describe here is, let's say you are in a space where you have access to a Wi-Fi network. I arrive into that space and I don't have access to the Wi-Fi network because it is password protected. My carrier is not providing me coverage, and I want to access to the internet. Then if you have Open Garden software installed on one of your devices, it can be your phone or it can be your laptop, then I will be able through my laptop or through my phone to access to that Wi-Fi access point. So basically it not only provides me with access to the internet, but can also increase the range of access for this Wi-Fi hotspot, because I can be hopping onto a device that's then connected to another device that has access to this Wi-Fi hotspot.
Wow, that as a consumer. Okay, so let's dive into Open Garden a little bit and the consumer applications of this, and then we'll get into these other the repressed consumers. That sounds to me like paradise, like a communicator's paradise, where as long as I have access, then other people can use it. As long as somebody else has access, then I can use that. But it also sets off alarm bells to me in terms of my devices already have very limited battery power, and now I could be sharing my connection with other people and using my battery life. And then I cannot imagine that the providers of gated connectivity, whether it's a paid Wi-Fi hotspot or my cellular carrier, are cool with the idea of me repurposing, enabling people that are not subscribers to use their network. So let's talk about first the consumer device impact, and then get into the economics.
So there are batteries, obviously an important point when it comes to mesh networks, and more specifically when it is an application like our application that is installed on a mobile phone. When we arrive in a place where there is density of devices, the mesh actually can create good opportunities for battery consumption. And I give you a very simple example. Let's say your phone is full on battery and my phone is very low on battery, and I want to access to the internet. Then instead of using my expensive link, which will use my 3G or 4G radio interface, I will just use a Bluetooth link to your phone, which is full on battery, and then be able to access to the internet.
My phone is full of... You are French, aren't you? Because this is such a socialist idea. So now we take your empty battery and my full battery, and now we've both got half battery life left. But I'm the paying customer, and I don't know you. So you think that the people will go for this? They will suffer a hidden battery in order to help to give back.
So first, in that scenario, I extend my battery life. Obviously, it's going to take some of your battery.
Yes. Okay. Go ahead. Yeah.
And there comes we want to create a system with credits. So basically, and this will require more iterations. It is not implemented yet into our software, but the more we advance into the implementation of the features of the software, we will test and create a credit ecosystem. So the more you give, whether it's bytes or it could be also joules if we for battery usage, the more credits you get.
And joules as an energy joules.
Absolutely.
Okay.
And then you can use these credits when you need connectivity, when you don't have access to an available Wi-Fi hotspot, or if you are traveling, for example, and you want to avoid expensive roaming charges. Yeah. And why not also reward users when they give some of their battery to some other users?
Interesting.
But that will require iterations, obviously. And we are not there yet, but that's where we are going.
Now, I know you've looked at this from the economics and the political perspective from the carriers, and Sri, I imagine you have as well. I mean, Tropos was, it's now doing power infrastructure, but it was broader than that when you started. So talk about the economic and business angle of sharing network connectivity. And this issue goes beyond mesh. I mean, when people started opening up Wi-Fi hotspots in their homes, the ISPs began to get really upset that people would be sharing their Wi-Fi with people they didn't know. So how does this play out?
Yes, I think that's a very good question, and Misha's points about credits is also very spot on. The carriers actually welcome the use of Wi-Fi now because their networks are so overloaded with the data. And in fact, it's one of the advantages of mesh is it's actually more power efficient. And the reason is that when you're communicating with a cell tower that's miles away, your cell phone has to burn a lot of power just to send like a voice signal. Whereas if you're hopping through several intermediate points just to get that cell phone or going through Wi-Fi, it's a much closer link and much less battery power. So you can get much longer battery life, much less strain on the cellular network. And so they're actually welcoming alternate approaches to offload their network. And so now the carriers are actually willing to embrace these new sort of off-network approaches, and I think that's where companies like that do peer-to-peer meshes or do Wi-Fi-based solutions will actually benefit the carriers and use unlicensed spectrum.
Have you worked with carriers, Misha?
Yes, I worked with carriers in the past, more in the voice over IP field.
But for Open Garden,
And for Open Garden, we started discussions with many mobile carriers. We have agreements in place to start tests with some of them.
Really?
And what Sri was pointing out is very relevant, is that today we arrive to a point where there is a limit with the spectrum that is available. And the only way to improve the wireless networks is to increase the density of microcells or hotspots. And I think carriers really understood that today because they are now rolling out their 4G infrastructure, but the next step will be probably to increase the number of microcells to improve connectivity and coverage. And what we do with Open Garden is we fall into that category where we turn every device into a hotspot or microcell. And by multiplying the density of these devices, then we improve the network itself. Becomes more reliable, can have impact on less battery consumption, as Sri mentioned, and obviously provide you with better connectivity and faster connectivity.
So you launched this product. Is it in release or beta right now?
So the product is still in beta. It was launched during TechCrunch in New York, end of May 2012. And we have a month later close to 150,000 users now.
Are there any geographic concentrations?
So more than half of our users are in the US, large cities mainly. And the second country now is India. And then countries in Europe like France, UK, and then in South America, Brazil.
Any big cities in the U.S. where, I mean, is it New York, San Francisco, the usual suspects, or are there like weird pockets that you're noticing?
The usual suspects.
Okay. Now, I want to get on to Sri, to you just 1 second here. Open Garden is available on OS 10 and Windows, so for laptops, and on Android, but it's not available yet on iOS, which strikes me as kind of the obvious place where we want this. When are we going to be able to get to bypass AT&T Verizon on our for data on iOS?
So obviously we want to go on iOS, and we started with an open platform, and Android is perfect to build this application and to arrive to a point where we have a really great user experience, completely polished user experience. And when we arrive to that point, then we will start working on figuring out how we can release the application for iOS. We have a lot of demands already from users on iOS, and we want to do it when the timing is right. And we believe we still have to work and improve the product. But I mean, it can happen next year. But it's obviously we want to go on iOS.
Yeah, cool. All right, now let's from the first world problem of going to a conference and not being able to get a solid connection to the real world of people who need to communicate in order to save lives or perhaps their entire country. Sri, I want to talk about what you've been working on since you've left Tropos. You sent me this paper about about using mesh networking as a way to route around intentional blockage of communications.
That's right.
Talk to us more about that.
Yes, having built about 850 cities across the world at Tropos Networks using Wi-Fi meshes, I've learned a lot about what makes them work and where they don't work. And so there are certain physical limitations to the current Wi-Fi based mesh networks, which the reason Wi-Fi is great is that the cost is so low, it's everywhere.
Mm-hmm.
And that's one thing that's made it so successful around the world. It's also available in unlicensed spectrum, which is available in pretty much every country around the world, so anybody can be free to operate without any license. And the challenge of Wi-Fi is that it doesn't actually, so users really want to take this and then spread it all over the world, but they can't because of the limitations of the physical layer. That the links can only go so far, and they require a lot of power for a battery-powered device to actually communicate over distances greater than 500 feet. Mm-hmm. Even 500 feet is a lot for a Wi-Fi device, battery-powered Wi-Fi device. And what I've been looking at is that, I see the energy that people have to build these meshes, and what they really want is something where they can just deploy a network anywhere in the world and start communicating over large distances.
Like the military does.
Like the military does. In fact, the military has been doing this for decades. In fact, for troops for over 10 kilometers getting, voice and video. And they operate from 20 megahertz to 2.5 gigahertz or 2,500 megahertz. They have radios that scale all that spectrum and then essentially have complete freedom of operation. These are called small unit operations situational awareness radios, and you can look it up on the internet, and they have tremendous flexibility. However, that's because they're the military. They can pretty much in a time of need they can operate in anything, and so what they also have is they have techniques where they have radio techniques that can, if applied in the unlicensed spectrum, can actually go 10 times as far and 10 times as fast, and so compared to Wi-Fi. And in many cases, so 10 times the coverage area of Wi-Fi because of the direct sequence spread spectrum and the frequency hopping and the way that the techniques they've developed. However, that's not part of the Wi-Fi standard, and they can scale down to very large, long links. Mm-hmm. And so that, I think, taking that kind of military thinking and combining it with the biggest trend in the world right now in technology is the smartphone. That the smartphone is even impacting everyone, including the military. They're having to adapt to the smartphone. That they're now realizing that their radios are have to somehow connect with the smartphones, and because everyone has one. Mm-hmm. And so, but the limitation of the smartphone is that it requires a cellular network. Is that and the many parts of the world don't have either they don't have a free cellular network or they don't have a cellular network at all. Mm-hmm. So many countries, there's hundreds of millions of people just don't have access to cellular networks. It's hard to imagine in this world where we carry ourselves, we're always with text messages and with video and so on, but there are hundreds of millions of people in the world that don't have access to that, and there's there's over 1 billion people who don't have access to basic websites that we all just take for granted in the United States. So they can't get information because of government censorship. So in all these sort of situations, I think if a new kind of radio layer that supports the social mesh concept could really make a tremendous impact in the reach of these networks. And so a lot of the problems we see right now could be just solved with the technology. And what's been limiting it so far is that these technologies that the military uses have been very expensive. They've been, maybe perhaps several $1,000s per unit. And now with the smartphone in our hand, we have so much processing power in these devices compared to 10 years ago that we can actually build very powerful mesh networks mm-hmm. from a processing standpoint. And you combine that with the Wi-Fi radio concept is actually 20 years old. The basic standard is 20 years old. There are much better with the new processing capabilities and with the new cost of RF chips coming down so much for the cost of for tens of dollars, you can actually build a much more powerful radio that sits, just like this battery pack here. You connect it to your mm-hmm. smartphone, and you have this very powerful radio that can connect just like the military radios.
And now, when we talked about this first, you talked about using this in instances where governments are actively trying to deny people access to the internet, to prevent another Arab Spring, for mm-hmm. example, by blocking access to Twitter or mm-hmm. shutting down the cell towers or yes. firewalling a country.
Right.
And you think that this technology can route around that?
Yes, I think so. For example, if you look at what's happening in Syria, there are a small number of activists that are using satellite connections, and they happen to be the satellite connections are very costly, very low speed, and for a very few number of people. And as a result, what's happening is that the governments are going in and trying to target the machines that are running on these satellite connections. So they're very vulnerable because there's so few of them. But when you have a technology like Wi-Fi at that Wi-Fi scale, but much more powerful, no, the scale, there's no way to stop that many radios out there. And so, it's just sort of there's a security in numbers. If you have much larger proliferation of these devices, you can overcome pretty much no government will be able to stop it.
So you're working on a new up-to-date radio hardware technology.
Hardware, software, networking technology. Okay. It's all you can't really separate. Yes.
Are you guys competing?
No, so I'm actually what I did is I wrote the paper. So we're not building a company yet, and so we've published this paper in IEEE Communications magazine. So we're looking into see how this is going to. I think there's a technological inevitability. I don't know exactly how it's going to unfold, but the power of these smartphones combined with the RF technology that's been developed for the last 10 years, at some point is going to change the way we do networking.
Go ahead, Misha.
I think. Sri and I are sharing the same vision.
Yes.
And the reason why we launched Open Garden is because the original vision was to take advantage of the density and the proliferation of smartphones. And like Sri said, which is a big difference like 10 years ago from now, is every smartphone, every phone is a computer, is a router, and has the capability to support mesh networking.
That's right.
And with the ecosystem of the apps on smartphones today, you just transform your phone into a mesh device just by installing an app. And but when you install Open Garden on your smartphone, it turns your smartphone into a mesh device. And as long as you have another device with Open Garden running at a close distance or in proximity, then these two devices will start to interconnect.
Now, as I said at the top of the show, I've been fascinated by this technology for many, many years. And over time, I have seen businesses experiment with shared infrastructure, shared resources. The one that springs to mind is Phone, F-O-N, which was a shared telephony network. It would replace your router in your house with one that was phone-enabled. And, you could then share that. There's another one of my favorite companies from a launch event, I think it was, called Space Monkey, where they're building a storage mesh, where they'll sell you 1 gigabyte of storage and a hard drive that you put on your network in your house, but it's actually a 2 gigabyte drive, and the other gig is shared with the mesh with the other users. Fascinating idea. Over the years, I have seen none of these technologies get critical traction. There always seem to be the province of geeks. Now, Sri, in your case, you're talking about routing around that particular problem by making it literally life or death for people. But Misha, in yours, how do you break out of, wow, that sounds really cool, and but it only solves a problem I have once in a while, and make this a really broad consumer technology to the extent that the carriers sit up and take notice?
So if you take the two examples you mentioned, Phone and Space Monkey, Phone, one of the things they have to overcome was the hardware. Basically, they tried at the beginning to work only with a software solution, but I think the hardware was not ready for this solution at that time. And Phone still has to deploy a number of hardware devices to be able to deploy their network. And that actually Martin is doing a great job, and I think now they reach like 4 million hotspots over the globe.
Really? Okay.
And I believe that the work that he's doing, and basically Wi-Fi networks, are very good complementary solutions to the peer-to-peer mesh application we are developing. Because when you create a mesh network, you always need off-ramp to the internet, whether it is through a carrier with a cell tower, whether it is through a Wi-Fi infrastructure. And in our case, why we launch and we think it is timely, it's because of the density of smartphones today. And we are not a hardware solution, and we don't want to be a hardware player. We are a software solution. And when it comes to software and to mobile apps, you are just 2 clicks away from getting your phone or your device, because it can be also a smartphone, a tablet, or a laptop, to become part of the mesh network and be a mesh networking device. So it's a very easy process. There is no more barrier of the hardware.
Mm-hmm. Sri.
Sure. Yes, I think as you pointed out, Misha, the big change that's happened in the last 5 years is the smartphone and the availability of smartphones that people are carrying on their, with them all the time, and so that opens up a new opportunity for Wi-Fi, and within the constraints of Wi-Fi, these meshes, these peer-to-peer meshes, will actually begin to become more and more available throughout the world, I think the complementary thing is that Wi-Fi itself as a standard is very limited, and so and there's nothing we can do about that. The great thing about it is the cost is so low; it's everywhere. The problem is that the limitations of the physical layer prevent it from really communicating at a long distance, and so it is technologically possible to build radios in unlicensed that have 10 times the coverage area now with new technology. And so eventually that will make its way into consumer devices at some point. For example, cordless phones use unlicensed spectrum, and they have much longer ranges. And that's just an example of how what's possible. But I think you can do much better using the military approaches that have been designed for military radios, and that it remains to be seen how that will unfold.
Fascinating stuff. So if we want to get mesh networking technology in our lives right now, there are a couple of ways to do it. Let's talk about that. Obviously, you can download and run Open Garden on your laptop computer or on your Android smartphone, and it sounds like kind of a no-brainer. You were telling me that if you're just running in the background, it actually doesn't impact your battery life very much at all.
Yes, the impact of the application itself is very low. You don't perceive it on your phone.
All right, so let's give it a shot and build a cooperative network. That sounds totally cool to me. Now, when you were at Tropos, you were involved in building these metro scale Wi-Fi mesh networks, and power companies are using these right now.
Correct.
Is that correct? So how is mesh being used right now, kind of behind the scenes that we don't see?
Yes. So, for example, smart meters are being deployed across the world to meter your residential usage, and those have to communicate back to the power company, and the way that's happening is over mesh networks.
Oh.
So they're connecting to networks where the mesh nodes are powered on the street lamps or powered on fixed areas where they have power, and they relay from hop to hop to hop back to the power the computers, the servers of the power company.
And then the new home control automation products, I think Zigbee, those are actually little ultra low power mesh networks.
That's right.
Yeah.
And those are designed for very long battery life to convey small amounts of information repeatedly over a long time, like 10 years.
Right.
And so those are in the home and low power devices.
So you wrote this paper on kind of new technologies and mesh as a tool for providing more people with connectivity, touchdown to the global net. What's your prognosis? What do you think is going to happen? First of all, do you think there could be another Arab Spring, given what potentially repressive leaders know about technology today?
It's a great question, and I can't answer definitively one way or the other. That's a very unpredictable. But I think there's a lot of things pointing to the answer being quite possible, because the technology is moving now in a direction where everybody can get very powerful communication resources in their hand, and I think I'm looking forward to the next 10 years to see how that's going to make it possible. And so when we wrote the paper in IEEE Communications, we were just asking the question: can you build a network that cannot be that's indestructible, a wireless mesh network that everybody can have access to? I think a lot of the problems in the world can be solved if you can have Ustream everywhere in the world, without being blocked. So Wi-Fi or cellular networks or anything, a government can take a very powerful transmitter and just jam the networks that none of it can operate. And that's just the vulnerability of commercial radios right now, is that they can be shut down. Similarly, the internet can be shut down by filtering the packets at any point in the entry points of the network. So many countries like Iran or other countries they can control the communication such that they only let the things that they want in and out going in. But technologically, that opportunity seems to be very limited, because if you have the power to communicate with everyone all the time, and one of the advantages of mesh networks is you can set them up, and there can be thousands of different links. There's no way for a government to control that many independent wireless links. They can just they may want to control these links, but they may be facing a sort of an unstoppable technological trend where there would be thousands of alternate routes in and out of these countries, and there's no way for them to stop it.
It's fascinating stuff. Sri Krishna is founding CTO of Tropos. Tell people where we can find this paper. What should we Google to find it?
Sure. You can Google my name and social mesh.
Social mesh.
Social mesh, yeah. And it's published in IEEE Communications Magazine.
Check it out.
In June. Yeah.
In June. Okay. Awesome. Thank you for coming in.
Thank you.
And Misha Benoliel is the founder and CEO of Open Garden, a mesh networking technology you can get today for your laptops and for your Android phones and the iPhone later. Thanks so much for joining us. Best of luck to you.
Thank you, Ralph. And so you just need to go to opengarden.com,
Yep.
and we will direct you to the right software to install on your laptop or your Android phone.
Great. Thanks, guys, very much for coming in. Thanks for watching Reporters Roundtable. Our next episode coming up will be on aerial drones. We've got Chris Anderson, the editor-in-chief of Wired, and Daniel Suarez, the author of a new book called Kill Decision about aerial drones, and previously the author of Damon, which I'm sure everybody here has read. Don't miss that show. Thanks for watching Reporters Roundtable. Thanks, Stephen, for producing. We'll see you next time.